Hola, hi, this is Al, your statistics and probability instructor. Let's get to work. In this video, we will talk about the variance. First, let me answer this question. What is the variance? Well, the answer is the variance is a measure of variability of a random variable y, a generic random variable y. Recall that the mean or expected value of a random variable provides us with a numerical measure of its center. Okay? So, to supplement that numerical description of the distribution of a random variable, well, we provide its variance. Is it clear? Okay. So, next, let me give you the definition of variance. So let y be a generic random variable, right? And then the definition of variance is going to be this. The variance of a random variable y, a generic random variable, is going to be an expected value that looks like this. It's the expected value of y minus mu square where that mu, that lowercase Greek m, represents the expected value of y. Okay, so that's another way of referring to the expected value of y, mu. And if you want to be sometimes you're going to see this notation. If you want to be super specific, if you're dealing with more than one random variable, you use a subscript so you know which random variable you are referring to. Okay, so that's the definition of variance. It's, as you can see, the expected value of a function of the original random variable y. Okay. Now there is something called the standard deviation of a random variable, and that is just the positive square root of the variance of y. Okay, so standard deviation, and sometimes people refer to the standard deviation using the following notation: sigma, and let's be super specific. In this case, it's the standard deviation of the random variable y. Okay. By the way, if you prefer that sigma notation, then another way of referring to the variance would be this. The variance of the random variable y is denoted by sigma square, and sigma is just a lowercase Greek s. Okay, so anyway, standard deviation, sigma of random variable y, we said is just square root of our variance. And let me write it down like that so you remember it. Okay? Okay. So, let's continue our discussion about the variance. Let's talk about an example. Okay, let me give you an example of the computation of a variance for a particular random variable. So, in this case, the random variable that we're going to be interested in is y, and y represents the number of cars that are used for official business purposes on any given work day. Okay? So it is not always the same, so we have a random variable. Now, consider that random variable for two different companies. Okay, we have company A, and I'm going to give you the probability distribution of y for company A. So for company A, and remember, the probability distribution of y is just a list of possible outcomes, possible values with the corresponding probabilities. Okay, so here we go. I'm going to be giving you that list of possible outcomes. So it turns out that in the case of company A, y could be 1 or 2 or 3, and corresponding probabilities are 0.3 for 1, 0.4 for the second value 2, and 0.3 for the last value. Okay, again, let me underline that a probability distribution must satisfy certain properties. One of them is each of these numbers must be a number between 0 and 1. They clearly are, and the sum of all of them equals 1, and that is the case 2. Okay, now let me give you something similar, meaning a probability distribution for a second company, company B. So I'm going to give you again the probability distribution of that random variable y, but for a different company. Let me copy and paste this. So possible values of y for company B are 0, 1, 2, 3, and 4. Okay. Now, corresponding probabilities for each of those values: 0.2, 0.1, 0.3, 0.3, and 0.1. Got it? Okay. Again, these numbers satisfy those two conditions. They are numbers between 0 and 1, and the sum of all of them equals 1. Okay? So it's a legit probability distribution. Next, let me show you a graphical representation of these two probability distributions. I think I have them here. Yeah, there they are. See? That's for company A. We have only 3 possible values, and here on the vertical axis we have the corresponding probabilities. Okay? In this case, it is clear that the center must be 2 or really close to 2, right? Just from that figure. Now, let's see. I think I have, yeah, the graphical representation of the probability distribution for this random variable y, but in the case of the second company, right? So this one has more values, right? And maybe the center is also close to 2, just from the figure, right? But what we can tell from just taking a quick look at these two graphical representations of the probability distributions, right, is that this one has more variability, right? Worst case scenario, 0. Best case scenario, 4. The other one, right, just has these 3 values, and as you can see, the range of variation is smaller, right? Okay, by the way, another way of referring to a probability distribution for a discrete random variable, this is a discrete random variable, right? It has a finite number of possible values that it can assume, right? So anyway, some people refer to these graphical representations or the tables that we presented for the probability distribution of a discrete random variable as probability mass functions. Okay, just in case you hear that term, it's just fancy jargon for the probability distribution of a discrete random variable, probability mass function. Okay, anyway, let's keep going. Okay, so as we said, from these graphs it is clear that the random variable y, the number of cars used for business purposes on a work day, that random variable has more variability in the case of the second company, company B. Okay? Okay, so what we're going to be doing next is finding the variance for both of them, companies A and B, and we will find out if that variance, that special expected value that we defined, reflects that fact. Okay? Okay, so here we go. Let's find the variance for company A. As you can remember from the definition, let me go back to the definition. Well, in order to find the variance, you need the expected value. Okay, so first step, an intermediate step to find the variance is finding the expected value of the random variable of interest. Okay, so here we go. As we have been doing it, we are going to be using the definition of expected value to find the expected value. And as you recall, it's just, hey, do this multiplication, possible value times its corresponding probability plus possible value times corresponding probability plus corresponding value times corresponding probability. Make sense? Okay, and you do that for all the possible values of the random variable. Okay, so in this case, what we have is 1 times 0.3 plus 2 times 0.4 plus 3 times 0.3. That happens to be 0.3, 0.8, and 0.9. You guys agree? Okay. So that would be 1.1 plus 0.9. That's just 2. Okay, so that agrees with what we saw from that graph. Just from looking at the graph, we said, hey, you know, it seems that the center of that probability mass function, or of that graphical representation of the probability distribution, just from the graph, the center must be close to 2. It happens to be exactly 2. Okay, so we have the expected value of y for company A. Now, to find the variance, remember that the variance is the expected value of a transformation of a function of the random variable y. Okay? But from another video, we have already said that the expected value of a function, a generic transformation, a function of the random variable y, g of y, would be this. So let me just say that. Recall that the expected value of a function of your random variable y is the same as this. Compute that transformation for each of the possible values, multiply by the corresponding probability of observing that particular value of y, and do the sum for all y's. Make sense? Remember? Right? Okay. So that means that in the case of the variance, let me use the definition of variance. By definition, variance of y equals expected value of y minus its mean, the mean of that random variable y, a Greek m, a Greek mu, uppercase. Okay, we have a square here. Okay, so that's the definition of the variance: expected value of your random variable minus its mean, the whole thing square, right? Using this theorem, which I think in our textbook is theorem 3.2. Theorem 3.2, I believe. You can check that later in your textbook, but I believe that it's theorem 3.2. That's what they call it. Anyway, so using this, so what we need to do is the following. Compute the transformation, right? So in this case, it would be the first value for y would be 1. You guys agree? We have only 3 possible values, 1, 2, and 3. 1, 2, and 3. Okay, so here we go. Compute the transformation for that value. So it would be 1 minus the mean, which is 2 square times the probability of that possible value, the probability of y equals 1, and that probability happens to be 0.3. So 0.3. Do the same for the next value. Okay, the next value is 2 minus its mean. The mean is 2 square times the probability of y being equal to 2, which is 0.4. Finally, last value would be 3, right? That's the other possible value, minus the mean of the random variable, which happens to be 2. You square it times probability of observing a 3, which is 0.3. So we do the math. This is -1 square, that happens to be just 1, times 0.3. 2 minus 2, 0. So that's nice. 0 times 0.4. And then this is 3 minus 2, that's 1. 1 square, it's 1. 1 times 0.3. And then what we end up with is clearly 0.6. That is the variance of y. Make sense? Okay? Okay. Now, for company B, what I would like you to do is this. Company B, so you know that our ultimate goal is finding the variance of that random variable y in the case of company B. What are we going to be doing? We're going to be using the definition to find the expected value of y in the case of company B, right? Okay, so what I would like you to do later today is use the definition and convince yourself that the expected value of y is 2. Okay, so that's please check this. Please check this. Homework. And now what I'm going to be doing is I'm going to be again using the definition of variance to find the variance in the case of company B. Okay, so here we go. Let me use this. Definition of variance is just that special expected value, that expected value of that transformation. So in this case, let's refer to the probability distribution or probability mass function of the random variable y in the case of B. So we have more values. We have 1, 2, 3, 4, 5 values, and we have more probabilities, right? So the first one, the first term when trying to compute the variance would be 0 minus expected value 2 square, so 0 minus 2 square times 0.2. You guys agree? So let's do that. First one, 0 minus 2 square times probability of observing that value, 0.2. Next one. So it would be, the next value would be 1, right? 1 minus expected value, 2, square it times 0.1. Okay? Here we go. Let's do that one too. So it would be 1 minus 2, then we square it times probability of observing y equals 1, right? Which happens to be 0.1. And then we do the same for the next value. The next value happens to be 2. The mean again was 2. We square it. And now corresponding probability 0.3. Our next term would be 3 minus 2, we square, we multiply by the probability of seeing a 3, and that happens to be 0.3. And finally we have 4 minus 2, we square, and times probability of y equals 4. Okay, and that happens to be 0.1. We do the math, right? So it would be minus 2 square positive 4 times 0.2, that's 0.8. Next one, minus 1 square, that's just 1, times 0.1, 0.1. This one is, it's a beautiful 0, so we don't have to worry about that guy. Let me be lazy, I'm going to just ignore that guy. Then we have 3 minus 2, that's 1, 1 square, it's 1, times 0.3, we have 0.3. And then 4 minus 2, that's 2, 2 square, 4 times 0.1, 0.4. And let's do this. Let's use R. 0.8 plus 0.1 plus 0.3 plus 0.4. There we are, 1.6. Okay, let me just point something out. The variance for that random variable y in the case of company A was 0.6. In the case of company B, it's 1.6. So, as we expected, the variance is greater for company B. Okay? Now, I would like you to notice something. Notice that the units of the variance are square cars, which is odd. So, people use the standard deviation, so they have a measure of variability with the same units as the original variable, right? So in the case of company A, the standard deviation would be just the square root of 0.6. Standard deviation for company A would be just square root of 0.6. Okay, and we could find it like that, right? Square root of 0.6. There we are. Roughly this. Roughly that. Okay, and something similar for this guy, right? So standard deviation of standard deviation for company B would be just the square root of that guy, 1.6, right? Okay, so roughly that. Now, again, let me remind you why people care about this measure of variability. Okay, because the standard deviation, is measured in terms of the same units as the original random variable. Okay. Okay. So let's summarize what we did today. Okay, so what we did is we defined the variance as a special expected value, the expected value of a transformation of the original random variable y. Okay, this is the definition. Okay, we mentioned that the standard deviation is related to that measure of variability like this. It's just the square root of the variance, and some people prefer the standard deviation because the standard deviation is a measure of variability in terms of the original units of the random variable of interest. Okay? Well, that's it. Please take care and keep working hard. See you next time. Bye.